According to my experience works based on the following outline, introduction, research problem, objectives, research direction, research and conclusion. Let me introduce my research. Firstly, now the Indian tin oxide thin films are being extensively utilized in displays such as liquid crystal display and touch panels because of their auspicious electrical conductivity and optical transparency. The surface shape and thickness of ideal thin film must be easily so restrained to progress their reliability and performance. And in the research problem is difficulties on thickness measurement of Indian tin oxide thin films to an uncertainty of nanometer range. And the solution is to measure the thickness of the thin film based on the phase modulation with interference signal, optical band difference, error value, and also thickness value. Objective is to achieve better performance of the thin film thickness measurement in the range of nanometer scale. In this research, the experimental result and the measurement result were met the high-performance applications in real world. Background methodology is the interference signal contains amplitude and phase. So amplitude and phase is very important. Therefore, error Z must satisfy the below equation. Error Z must be less than 0.02 radian and error alpha must be less than 0.05 radian by the mentioned equation. And also we use the first Fourier transform. So we use the frequency components. So we can get the Z1, Z2, Z3 from the frequency components ratio, and alpha is the tangent inverse frequency components ratio. By using the Z1, Z2, alpha, and Z3, we can get that this theoretical graph, error alpha and error Z and alpha gap. Again, this is the analog to digital circuit configuration. Analog to digital circuit configuration contains function generator. Sampling frequency with the square wave is applied to the AD converter, and also carrier frequency with the voltage divider is connected to the AD converter from the control of the switch. And PZD is given by the function generator, the signal of the sinusoidal waveform. So PZD is displacement by the function generator. And also research direction, this is the sinusoidal phase modulating interferometry. This contains 5 main parts. They are laser diode, mirror, reference mirror, photodetector, and PZD. Laser diode splits the beam into the beam splitter. Beam splits the mirror and also the reference mirror, and they are striped back and reflected back, and also forming many types of interference waveform. Therefore, a photodetector detects the interference signal, and this interference signal from the photodetector can be to the oscilloscope and the AD converter. From this AD converter to the computer, by using the MATLAB and LabVIEW software, we can calculate the ZB and alpha. So in this, PZD can control by the function generator. This is the sinusoidal phase modulating interferometry implementation. This is the workflow diagram of thickness measurement in interferometry laboratory. Firstly, we can get the sinusoidal phase modulated signal. It contains ZB and alpha. ZB is the amplitude and alpha is the phase. So we can get ZB, alpha, and also the optical band length, and also get the optical thickness, and also to the thickness of the thin film. And then this is ZB and alpha is the very important. So in this research, we may calculate the ZB and alpha. When the reference mirror to the PZD, we can get the SRT equation. By using the theoretical values of L alpha, we can get the Z value is around 2.6 at alpha pi minus 2. So therefore, we trust the experiment for Z around 2.6 and alpha equal to pi by 2, around the pi by 2, and we can get the amplitude voltage and DC offset voltage. And then calculated values for average error value for thickness measurement by using the alpha value 0 to pi minus 2 with the interface of 0.1. We can get the average error Z1 value and average error Z2 value. And average error Z1 is the range just from 0.001 to 0.6, and average error Z2 is range from 0.000 to 0.06. And other results are average of the error and alpha graph values. We gain that just again and again the at least 3 cases. This is the three case: first case, second case, and third case. For every Z1 and Z2, we use the Gaussian noise and use the magnitude of 0.1. And this is the simulation testing the 5 interference waveform at z equal to 3.4 without noise at alpha equal to 0 to 1.5. And also can test the experiment for 5 interference waveform at z equal to 3.4. We can get that this waveform. And also we compare the experimental and simulation results at z equal to 3.4, and we can get like this. And so this is similar the situation. And also again test the comparison result of error value for thickness. So average error Z1, average error Z2, Z3. This is the combined graph, and this is the same with the theoretical graph. Let me conclude my presentation. In the certain measurement, we can get amplitude that is constant at around 3.4 radian. But in the experimental result, we can get the Z value is near around 3.4 radian. There are differences between simulation and experiment because noises, echo, effect, vibration, and sound, and time gap. When investigate the amplitude error value, use the random noise. The error must be also the random value. Finally, the thickness of the transparent plate with an actual thin film on the top surface will be measured in the future. By using the proposed method, it becomes possible to measure the surface area and thickness of the thin film simultaneously with reducing cost and time. Thank you very much for your attention.